Right. So today we are going to cover the LO2 of the Advanced Database Management Systems. Yeah. And what we covered last time is data models, the database management systems, specifically MySQL and Oracle. Did you get the chance to go through those, websites?
Yes, I had a look through those websites. They're very good.
Yeah. So at least they would be able to would be helpful and good for the practice, isn't it?
Yeah, absolutely, yeah.
Yeah. So good stuff. Then we have been discussing a lot, like we discussed constraints, relationships, normalizations, and the three levels of schemas, and there was a good discussion on the transactions and concurrency control, isn't it?
Yeah.
Yeah. So it was a good idea, and now today is apply data modeling techniques to refine logical data requirements and normalization. Yeah. So normalization is basically the optimizing the database design. Yeah. Optimizing
Yeah, okay. Yeah.
database design. So like I said previously that it's based on chapter 4 and 15 as well. And we will be following one book at the moment.
Yeah,
Yeah.
okay.
So and then in today's LO is the UML, and the UML is the substitute for the entity relationship diagrams, and XML for data as well. Can I ask, how much do you know about the XML, and do you know any relationship of the XML with the databases?
No, I don't, but I'm confident I can learn it.
Yeah, that's good. So, did you ever get the chance to play with the XML?
No, the only thing I have played with on that list is the CSS.
Yeah,
I've done CSS before, but not XML.
XML. Okay, that's good. That's fine. So we'll discuss today the XML,
Yeah.
the DT, and obviously the CSS as well. So let
Yeah.
me complete these, few things first, and then we come back to this. Yeah. Advanced databases, LO2, part 1. So unit ends are same. So overall the topics, today are the first normal form, second normal form, the biscore normal form is basically the extension of the third normal form. Yeah. So
Okay.
query language processing is a one kind of role. Yeah. It's basically a kind of slightly research topic. There isn't much enough available on this. Yeah. So let me show you. That's basically the let me show one thing. Yeah. Entity relationship role oriented query language. Yeah. So
Okay. Yeah.
the module has, whosoever has designed this module, they have randomly just forcefully put this topic, isn't it? You understand this?
Yeah.
However, with the conventional databases, this is not the kind of normal topic. So it would be very simple if you would simply, let's say, tried to include few of the definitions, yeah, from the different sources, yeah, then they would advise that how would you, execute a query language based on the role specific, yeah. Would it be okay? You
Yeah.
would be able to find the definition. Maybe, I will help you to send the relevant, the research papers as well. However, on the Google, yeah, there isn't much enough, available into the, uh, you know, even in the books or on the Google, yeah. So in order to comply
Yeah.
with, yeah, in order to comply with the, let's say, awarding body requirements, yeah, we are not saying that, we are not including this into the assignment because there isn't much, stuff available, but at least, uh, this paper, yeah, would be helpful, yeah.
Have you got that paper? Have you?
I will manage, for this for you.
Okay. You can you send me that? Can you?
I mean, yes, if I will have this, directly available, I will send you. Otherwise, I would, get it for you from someone else.
Okay.
Yeah.
Yeah. Okay. Yeah.
Right.
Yeah.
So maybe Raman could arrange, or on my own resources. Yeah. So, but at least you should be able to edit. Yeah. Then, the schemas, relationships, roles, and cardinalities. They are the normal, topics, isn't it?
Yeah. Yeah.
So, with connection to the previous lecture again, we will be referring this, the fundamentals of database systems, and the this book chapter 15 would be based on the normalization, and UML stuff would be from, let's say, chapter 3 and 4, and the XML thing from chapter 13. Yeah.
Yeah.
Okay. So let us move on. So database schema, like, there is these are the topics, included into this LO. That's why I have repeated. However, I believe you should be able to understand this very well. You must have gone through these conceptual internal and external schemas, isn't it?
Yeah. I remember all that.
Yeah. And then entities and the design, and the relationships, the symbols, and the dictionary, and the cardinality, like, they have mentioned here, yeah, roles and the cardinality. So in order just to, if you needed to include, like, in the task they said you need to express the cardinality, the, the relationships. So maybe this PPT again should be helpful for you to include the things. Is that right?
Yeah.
Yeah, because, the regarding the assessment, and the especially the, the quality focal person in university and the Raman, they make sure that whatever the assignment is asking, has the student included or not.
Yeah.
Yeah. So even if we say that, you have studied this, yeah, you have repeated into the, LO1, but it would be better that just, we need to answer and include, these assessment criteria, isn't it? Would it be sensible?
Yeah.
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 Okay, good. So the keys and primary keys, and now the most important topic is the functional dependencies. Yeah. So the functional dependency topic is basically the grounding for, the normalization. So what happens when you really need to normalize the, tables? Yeah, it means you need to remove the redundant data. Yeah, or the data and the fields depending on each other. Yeah, which is basically called the dependencies. Yeah. So if you understand the dependency and if you can minimize the dependency, then the design would be functionally efficient.
Okay.
Yeah, you understand these, sentences now.
Yeah, I can. Yeah, I can understand what's on that slide there. Yeah.
Yeah. So in order to do the normalization, we need to understand the dependencies of functions, basically. Like a functions,
Yeah.
basically, yeah, they call, and this now, basically the language is going to be little bit more mathematical.
Okay. Yeah.
Yeah. So the mathematical language and when they write about the dependencies, so they basically mention with these arrows. If X is dependent on Y, yeah, then they write with the arrow. Did you ever get the chance to study the mathematical way?
No, I didn't. No.
Yeah. So there would be lots of, when there is a big chapter, yeah, and lots of, if I would start the chapter 14 here, yeah, then it's not that much difficult, yeah, but they have started with, writing formally that what is the functional dependency and how you need to understand if there is X and Y, if there is Y and Z, and if there is Z and, P, Q, R, S. So like means, if you would assume that things are, one of the fields, one field is dependent on another thing and another thing is dependent on, the third thing. Yeah, so transitive one. So simply,
Okay.
simply it would be wise, it would be good to look at the as much as possible number of examples, yeah, and then we can understand, everyone can understand, the complexity and the, uh, unnormalized forms into these, the database which we are working for. Do you agree?
Yeah.
I mean, if you are sitting on the database, for example, and if you are trying to think that which functional dependencies exist into particular database design, then without looking at 5 or 10 kinds of examples, we cannot identify. Make sense?
Yeah. Okay.
Yeah.
Yeah.
So it is advisable. Obviously, we cannot go through the all topics, from the A to Z, like what's the functional dependency, and then, for example, if it is a first normal form, second normal form, then just first normal form, for its examples, and going through the tables and deleting, a particular table and how it would be affecting, the it could be a very big lecture, isn't it?
Yes. Yeah, I
Yeah,
get that. Yeah.
yeah,
I need to read up on this as well.
a little bit. Obviously, because if you could understand that the model of the UK was and obviously they could best support, yeah, what they can do, and little bit self study is required. Yeah.
Yeah, of course. Yeah.
So the functional dependency, if there is a functional dependency, then there exists some anomalies. Yeah, anomalies are, the unexpected errors, yeah, that you find while you insert, update, or delete. Make sense?
Yeah.
So the functional dependency leads to some anomalies, or, the, I wouldn't say error, basically like a syntax errors, but the semantic errors, basically they call us semantic. So logically, their results would be affected. So while you insert any record, while you update any record or delete any record, that's why you need to, normalize. So functional dependencies, yeah, that was the next slide I explained earlier. Yeah, so it happens. I think you have already studied in this as well.
Yeah. Okay. Yeah.
So simply, if it is a first normal form, so let's say here, the first normal form says that the value should be atomic, but it should not be multiple values. Like, the color cannot be stored. Let's say the product one cannot have the red and green color, isn't it?
Yeah.
Yeah, so you need to split the color separately and associate with the product ID. If the one of the column is repeating, for example, the product ID is repeating, but at least this atomic values are being satisfied, isn't it?
Yeah.
Yeah. Then second normal form says that for example, store ID is basically repeating with the customer ID. Let's say store ID 1 is the Los Angeles, and again the in the same table, if the records could be, for example, the customers did the purchasing from Los Angeles, let's say 100 times. Yeah, then what you
Yeah.
would be doing there, you would be referring the store ID 1 and Los Angeles purchase location for 100 times the Los Angeles and 100 times for the store ID. Do you think you would be wasting your storage?
Yeah. You would.
Yeah. What you need to do, you create a separate store ID, a separate store table. Let's say Los Angeles 1, and obviously there would be much more information related with the uh, location, yeah, of the store, yeah, from the one in the Los Angeles, their address and blah blah blah. So simply you created a table, you only utilized, yeah, the 2 columns and 3 rows is space, and then you quickly insert into, let's say, purchase table that the customer 1 did the purchasing from the store 1, yeah, and hardly, let's say, even if there are, let's say, 1,000 customers, yeah, for the 1,000 customers you are only, let's say, utilizing the column 1 as maybe a byte or 2 bytes maybe. Yeah, so how 2
Yeah.
bytes, like a 1 byte can store like a 256 values. Yeah,
Okay. Yeah.
so if you would be using a 2 bytes value, yeah, then let's say you can store 1024 values.
Yeah. Okay. Yeah.
Yeah. Do you remember these, the byte numbers and how they are, increasing?
Yeah. Yeah. So it
Like
goes. Yeah.
a bit like a binary digit 0 and 1, and then, one bit, bit can store 2 values, and, 2 bits can store 4 values, isn't it?
Those. Yeah. And yeah. And then 8 and 16 and so on. Yeah.
Yeah. So
Yeah.
1 byte can store 256 values. Yeah, and then for the 1,000 you require 4 bytes maximum,
Yeah.
right? In this way, if you could imagine, if the Los Angeles was repeated up to 100 times, then it would have wasted hundreds of the bytes, maybe hundreds of the megabytes, if the further information was available, isn't it?
Yeah.
So that's basically the normalization benefit.
Cool.
Yeah. So in the third one,
Yeah.
what happens? the if price and this is a book store and the genre type, for example, gardening, sports, and the genre ID, yeah, itself is basically they are transitively dependent. Yeah.
Yeah.
Then obviously, let's say genre type and ID, they have the close relationship. Instead of mentioning the genre type every time, yeah, they have done the same trick here, that give genre ID like a genre type and ID in a separate table and just keep on repeating or using this genre ID only.
Okay.
Like the what they did here, they associated the two things into one.
Yeah.
So previously the price was depending on two things, isn't it? Column B and column C. So what they did, they have merged the two things into one simply here.
Yeah, made it a lot better.
Lot better. And in the previous one, the one column was depending on the let's say the item location was dependent on the store ID. So instead what they did, they split it here, yeah, and made the life easy.
Yeah, of course.
So customer ID, sorry, the store ID is not dependent on the customer ID. Do you agree?
Yeah.
Why? Because the customer could buy from anywhere else, yeah, and any store could be could be used by any customer. That's why it's the location was dependent on the store. However, in the third normal form, the price was dependent on the type of the book, and the type of book got the ID. So simply the price was dependent on genre, yeah, and they reduced these two columns into one. Yeah.
Okay. Yeah. Yeah.
The, yeah.
Is this actually something that's done quite a bit in the on live databases?
Say again. Sorry, what's the question?
Is this something that's done quite on a regular basis, normalization, or is it just a one-off?
Yes, it happens basically. Yeah. So
Okay.
I can give you the example. For example, what used to be, for example, initially in the labs, students used to create, their own, databases for a particular organization. And if I don't give you, for example, if you are a new and you haven't studied the the what should I say, normal forms, then you would definitely come up with these redundancies.
Okay. Yeah, I see. Yeah.
That's natural.
Yeah, of course. Yeah.
Yeah, that's a good question. That do you really need to do this? But according to my opinion is, if you would once you would create this, then willingly, unless you are a very, if for example you have done these cases before, yeah, like you have done the database for the store, if you have done the database for the student ID, student registration system, if you have done this for the e-com store, yeah, if you remember everything by heart, yeah, then you may not be doing the, let's say, these mistakes. But if it's a new domain, yeah, then you would definitely in the first stage will commit, or I won't say that you would be doing mistakes, but you would be initially in the redundant phase.
Yeah. Okay. Yeah.
So you can try
Okay,
to
that answers it.
yeah, you keep this in mind, yeah, that at some point, you would definitely be having these problems, yeah.
Yeah, of
Okay.
course. Yeah. Okay. Yeah.
Vice code is basically the extended form of third normal form, or let's say the stronger form of the third normal form, yeah. So let us see
Okay.
how, like in this table, let's say property ID, and then the country name and the lot number and the area, yeah. So what's going here is, sorry, area, lot number, and the county name. Sorry, they are dependent on the property ID. Three things here, right? And furthermore, area is dependent on the county name, yeah. And area is also depending on the uh, property ID. So here the two functional dependencies are occurred. One functional dependency is basically that let's say property ID needs to use the county name, the lot number, and the area, yeah. And
Yeah.
area and county name is basically the, let's say, dependent on the property ID. So when it goes to the Vice code normalization, what you need to do, they have further converted the area and the uh, classified the area and the county name separately. So here let's say the functional dependency 1 is the C is dependent on only property ID, the lot number, and only the other dependencies that county name is dependent on the area.
Okay.
Okay, for example, if you forget this B, then are you a little bit clear enough? The area has been, I mean, the county name is dependent on the area now.
Yeah. Okay. Yeah.
And the lot number and area, yeah, they are only dependent on the property ID. Simple as that.
Right. Okay. Yeah. Yeah. Got
Yeah.
that. Yeah.
Yeah. So obviously, like I said, that this requires a lots of the more examples, yeah, and then it will be clear. However, this has been again, let's say, the a kind of third normal form where two of the values, the two of columns were placed and done kind of partition there, and same here. The area and the county name, they were kept on the side.
Okay.
Yeah. What was the
Yeah.
only difference? Yeah. In previously in the third normal form, the price was dependent on, let's say, genotype and gener ID. A was dependent on the B and C. In this case, let's say A was dependent on there are four things. A was dependent on B and C. Here, area is dependent on B, C, and A as well.
Okay.
Yeah, because the property ID must have to do something with the area. So what they have done, they have further tried to did you notice that this got not only the one transitive dependency, yeah, but it got a two transitive dependencies in this particular scenario.
Yeah. On the down the side.
Yeah, like area is depending on the property ID as well. So what they really rearranged, that probably the area could be the, let's say, primary key, and the county name could be its dependencies.
Yeah. Okay.
Yeah. So that's a bytecode normal form. I hope you would be able to understand if you would give it a more time, and feel free to ask me next time, and we can exchange the ideas with by sharing some samples. Yeah, is it okay?
Yeah, that's fine. Yeah.
Yeah. So, and then this one was a part one. Let's come to the part two. So UML is the modeling language for the databases, again schemas. Everything is same. Previously the the what I would say that entity relationship diagrams, like an entity used to have the attributes. Do you remember?
Yeah.
Yeah. And in the similar way that classes, yeah, when you talk about the classes, it means you talk about the object orientation concepts. Do you agree?
Yeah.
Yeah. And when you talk about the object orientation concepts, then you talk about three things: encapsulation. Yeah. In encapsulation, you list out the name of the. Can you see my cursor? If I'm moving here.
No, I can't see it moving.
Okay. Can you see now?
Oh, hey. Yeah, it's gone full screen. I can see it now. Yeah.
Okay. So when it comes to the UML based modeling, yeah, then it is giving a kind of flavor of object oriented database.
Okay.
What you need to do, if it was a relational database, then what would happen? Then let's say the store, the ID, the locations, the product ID and other stuff would have been stored into different places. There would not have been a good way to secure them, basically. So what would happen if you would be, let's say, creating the class based diagram? Then you can list out its attributes. You remember the entity should have been used to have the attributes as well, isn't it, in the entity relationship diagrams?
Yeah.
Yeah. So you could include the attributes. You could add the methods as well. Yeah. So only the required methods. Let's say if there is an imply, then you could quickly say imply age. Then quickly you can return the age of the imply. You can retrieve the date of birth. Yeah. It would be self iterative. Furthermore,
Yeah.
the association between the classes you can define well as compared to the, let's say, entity relationship diagrams, as well as inheriting the properties. The, like employee could be inheriting a dependent, yeah, or let's say the department could inherit let's say a particular project of the company, or particular department could inherit lots of things from particular department. Do you agree?
Yeah.
For example, there could be 10 projects under one department. So what would happen? The particular project would be inheriting lots of things from the department, isn't it?
Yeah. Okay. I get
So
the
yeah,
inheritance. Yeah.
yeah, inheritance. And the polymorphism is that the functions you are using here, and let's say if you have got the one function show, yeah, then just using the show function, if you would ask the employee to show, then what it would show to you, it would show the name of the employee, let's say. And if you would apply the function on the department, then it would show you the name of the department. Make sense?
Okay. Yeah.
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 If you would click on the function of the show on the project, then it would show you the name of the project. Yeah.
Okay. Yeah.
So that's basically the polymorphism.
Yeah.
Yeah. So at some point in the databases, when the object-oriented features are required, yeah, and then you are going to model your database, yeah, for the object-oriented database, then UML would be the best option to use.
Yeah. Okay.
Is that okay?
Yeah.
Yeah. So the second topic, so really depends, on the assignment. Whatsoever the extent they would be asking, you can explain the concept, from this side. Is that okay?
Yeah, that's fine. Yeah.
Right. Now, XML. XML is basically considered a kind of database as well. Do you agree?
I'm not sure really. I don't know an awful lot about XML.
So you can say that XML is the database, yeah, lying on the web.
Okay.
So do you want to note down these, statements?
Yeah.
Do you have the
Just
pen and
gonna.
paper?
Yeah, I'm just gonna
Right.
jot it down in Notepad. Yeah. Okay. Yeah.
So XML is the database on the web, basically.
Yeah. Okay. So XML.
And the reason is the data is stored into the text. Yeah. For example, if you remember in the HTML, we start a tag, and when we put the, let's say, paragraph, anything inside the starting and opening paragraph P, then, the browser would be showing to you the content of the paragraph, isn't it?
Yeah, that's fine. Yeah, I get that. Yeah.
You understand?
Yeah. I know HTML. Is it similar to HTML?
Yeah. HTML
Yeah.
is, similar to, sorry, the XML is similar to HTML, but
Yeah, I know
HTML,
HTML.
yeah. So XML is similar to HTML. The only difference is the interpreter or the compiler of HTML is the web browser.
Yeah.
Yeah. So who reads to the HTML? Obviously, the web browser reads it and displays the output to you. Make sense?
Yeah.
However, the XML is a kind of markup language. Yeah. And it carries the data into the text. Yeah. And its compiler one second. One second. Right. Yeah. So basically, so I was lost somewhere else. Yeah. So the document type definition is basically the compiler for XML.
Okay.
Now let me give you the idea that like HTML, who processes, when I say word the process means the compiles the browser. Is that clear?
Yeah, I get that. Yeah, that's fine.
Yeah. And you understand that for every language that you write, a kind of compiler or the program interpreter is used to compile for the the syntax and the to give the output. Is that right?
Yeah, I understand that. Yeah.
Then the XML is written into the tags. Yeah, you put the data inside the tags. Yeah, it means you are basically creating a data file. Do you agree?
Yeah.
Like if you are storing the data into table, yeah, then what happens? You create the names of the columns. Yeah, and
Yeah. Okay.
you put the data in. In the same way, in the XML document, what you need to do, you create a custom tags, and and inside a particular custom tag, you will store the data in particular tags. Yeah.
Yeah. Okay. Yeah.
Then, in order to process or traverse or compile, you need a document type definition language. Yeah. So
Yeah. Okay.
what would happen if you want that an XML file should contain the, let's say, the name of the student, the address and the telephone number. So what would happen if you would give that XML document to the document type definition to the appropriate compiler of the XML? If the sequence and the content, the number of tags would be matching, then it would be a valid document type against the DTT. Make sense?
Yeah. Okay. Yeah.
Yeah. If it would not be the valid data type, yeah, then it would give you the error.
Okay.
So what would happen? You would have a kind of example file, the XML files containing tags and tags. For example, uh, XML example. For example, this is a sample example. Then colors is the outer tag, and the color 1 is white, color 2 is blue, color 3 is black, color 4 is green. Yeah. Then fruits, apples, fruit 1, fruit 2, fruit 3. Now what would happen if you want this to be stored as a database? Then it requires a kind of language behind to validate that data. Make sense?
Okay. Yeah. I
Yeah.
get it. Yeah.
So the document type definition, and there are the advanced, the XML parser and many more things, yeah, which would help you to enhance the data formats. However, the rule, according to the rule, you should be able to store the data into the file, process the data into the XML file, retrieve the data into the XML file. Make sense?
Yeah. Okay.
Like why we are going to use the XML? Because XML is universally accessible. I mean, it is platform independent. Any platform
Yeah.
can read. That's the idea behind. Yeah. For example, the web
Okay.
service, you must have seen that at the back end of the many web applications, there is the XML code written, isn't it?
Yeah. Yeah. I've
Yeah.
seen that before. Yeah.
If you remember, we discussed the web services and the service-oriented architecture, the web WSDL, description of the service language. Everything is written into the XML, isn't it?
Yeah.
Yeah. If it is written in the XML, it means it requires to be read by something. It requires to be processed by something. It requires to be compiled by something, isn't it?
Yeah.
So the reason of introducing the XML here is that XML is a kind of database, is considered as a database. Yeah, because it has a supporting database management system in the form of the XQuery, XPath, the DTD definition language, the rules, and there is some mechanism behind in order to traverse that. For example, the fruits and the colors, it colors file, XML file, isn't it?
Yeah.
So if I would have asked you that here is a file, here are the 3 colors, 4 fruits, yeah, then by using the XQuery, you should be able to select from let's say table of the fruits, yeah, then where the color is, let's say, blue, it would give you the name of the tag. Where the tag number is 3, it would give you the value standing on there, yeah. And where the particular name of the fruit, number 2 fruit is apple, yes. And what is the name of that apple? It's a fruit number 2. Do you understand this?
Yeah, I understand. It's interesting.
Yeah.
I didn't realize there was
Yeah.
so much to XML.
Yeah, so like if the table is if the relational table is in front of you, and then if the XML file is in front of you, yeah, so both are basically stored, like XML is stored into the tree basically, and the relational database is stored into the database, yeah. And what would happen, yeah, similarly you should be able to process in the traverse. Basically there isn't much let's say insertion, updation, and deletion available there too much, yeah, unless you use any integrated development environment like IDE, yeah. But at least on the web, when it's a web project, then you can easily pick up the data, search the data, and communicate the data. Does it make a sense?
Yeah.
Yeah.
Yeah,
So
it makes sense now. Yeah, I get it.
yeah. Now, after giving you this, idea, yeah. So what happens that, like, DTD is being defined, like a sequence is defined by the DTD, that there should be a name, there should be, location. Like if you remember the JavaScript, isn't it?
Yeah.
So JavaScript runs on the browser dynamically. It could do some validations in the same way. That DTD language would allow you to process on the XML.
Yeah. Okay.
Yeah, makes sense. And for example, in the next examples, like if you created the university example is stored into the XML file here. So here is a root, then you created, for example, the student, then name of the student, section, blah blah blah. Here is the, let's say, the a kind of table is stored for the university database in the XML. Yeah, makes sense?
Okay, yeah.
Yeah, so here, then when you would define their sequence, yeah, here, and then you should be able to basically run the XML queries here, basically, like as an SQL. You understand this?
Yeah, I get that. Yeah.
Yeah, and you are getting the results in the form of tags. Like I was saying, you would get a particular tag and particular value, isn't it?
Yeah. Okay. Yeah, that's fine. I understand that.
Yeah. So because in the game of web, you would be looking at the values inside the tags. For example, if the Google is searching into a particular web page you created today or in a blog, the Google is not searching, for example, the database, isn't it? Because your web page is not a database, but it is the a kind of unstructured data into the web page, isn't it? Make sense?
Yeah.
Yeah. So that is basically a kind of poorly unstructured database. Is still some of the, let's say, processor would be able to extract, but if it was a pure XML file, even what I can say is a particular web page can display the dynamic content of the page by taking data from XML file. Do you understand this?
Yeah. Yeah.
Normally, the web page, the dynamic pages, they pick up the data from the server and display it to the web page, isn't it? But it is possible that the dynamic page could pick up the data from the XML file and could show to the web page. Yeah. So it's another game changer, switching from the conventional databases to the databases, a pool of the XML files, for the processing purpose and the quicker purpose. Only the disadvantage is that the XML is not secure.
No. Okay. Yeah.
So overall, this is the output. This is the query language with the XML, and you can represent the XML table here. You can store the data. You can define the XML file, and everything would be a kind of relational database, for example. And it is defined by the document type definition by following the rule, like we define the constraints rules on the similar tables. So same here you define, and you are good, and you can play with this. And how this is done, basically this is used to process with the structured data, even the semi-structured data, unstructured data. So in order to play with any kind of data, the XML is helpful.
Okay. Yeah.
Sorry, I didn't go into the detail of this XML, but I believe you got a full concept of using the XML as a database.
Yeah, no, that's fine. I'll read up on it.
Yeah. So wish you all the best, and I see you next week again. Yeah.
Yeah. Thanks a lot. See you next week.
Okay. Bye. No problem. Thank you.